Chapter 14, Geology and Earth Resources. Modern technologies require many resources that are derived from the Earth. The resources are formed through geological processes deep underground. Often, these resources must be dug out or mined from the ground to be available for our use. This mining often leads to serious environmental issues. In this chapter, we will go over a basic discussion of the Earth's geological processes, and then we will discuss how we extract resources and the environmental risks and damage associated with these activities. The Earth, much like soils in the atmosphere, is layered. At the center is the core made up of mostly molten metals. On top of the core is the less dense mantle riding the core. At the very outer layer is the crust. The crust is only 40 miles thick, but it is where all life occurs on Earth. An illustration of Earth's cross-section. Most geologists agree that the rigid crust moves across the mantle due to convection currents in the mantle. These currents break the crust into large tectonic plates that move away, towards, and side by side to each other. This motion causes earthquakes and volcanic activity. A map of tectonic plates. Where plates collide, you often get either mountains, the Himalayas, or subduction zones, trenches in the ocean. The amount of subduction is just offset by the amount of volcanic activity at oceanic ridge zones, where plates are moving apart. An illustration of tectonic plate movement. Through these tectonic actions, many rocks and minerals are formed. It is these rocks and minerals that we often mine. Rocks are classified based on how they form. There are 3 primary rock types: igneous, sedimentary, and metamorphic. An illustration of the rock cycle. The most common type of rock are igneous rocks. These rocks are formed by tectonic action. As magma cools, igneous rocks are formed. How fast the rocks formed and what the magma was made of impact what kind of igneous rock is formed. Once exposed at the surface, these rocks are eroded through chemical, physical, and biological activity. Sedimentary rocks are formed through the deposition of weathered rock particles that undergo compaction or through crystallization of precipitates from the solution. Animals are also important in the formation of some sedentary rocks. For example, the White Cliffs of Dover are the deposited remains of microscopic algae species living in shallow seas. Metamorphic rocks are rocks that are derived from pre-existing rocks that have been subjected to high heat and pressure. An example of this is marble, which comes from limestone, a sedimentary rock. Many rocks and minerals have an economic value. The extraction of these minerals often causes severe environmental damage. For example, I live near a limestone quarry that mines limestones for gravel production. Up until recently, all of the limestone was mined at the surface. The result is an extremely large hole dug out of the landscape. The mined limestone is crushed to form the gravel, but crushing produces dust and small particles that cannot be used. These often end up being washed into nearby streams. Additionally, some rocks contain chemicals that are toxic or hazardous. When brought to the surface, rainwater can leach these chemicals out of the rock, releasing them into surface waters. Regardless of the type of mining, all produce some level of damage. Placer mining is an old method that uses the water of the stream to separate the gold from the sediment. Most people think of placer as old miners swishing a pan in the river. While this is placer mining, modern methods use a large hydraulic cannon or large machines to mobilize large volumes of sediment to find the gold. This sediment comes from the stream bed. Underground is the classic tunnel seen in gold and coal mining. Shafts are dug or blasted that follow the mineral vein of interest. Because they are underground, they are often filled with gases and water. That water sometimes makes it to the surface, causing problems with water quality. Strip and pit mining are the preferred methods for minerals such as coal. Pit mining is the process used to mine the limestone near my home. These holes are often left empty once the mining has ended and the soil is not returned in strip mining. Both produce long-lasting impacts on the environment. Because of issues related to strip mining, the Mining Act of 1977 requires that strip mines replace the overburden once the mineral is extracted. Unfortunately, this is often ignored because the fines may be less than the cost to reclaim the area. Another form of mining that leaves piles of overburden is mountaintop removal. This method is used in the Appalachians to mine for coal. The overburden causes damage to surrounding rivers and streams, so industry leaders have been sued under the Clean Water Act. Many of the suits are still in the court system. A photo of mountaintop removal. Finally, we have spent a lot of time talking about mining and its impacts. Processing the ore also impacts the environment. For example, the use of heap leach extraction, where chemicals are sprayed over the ore to leach out the gold, have led to surface waters being polluted when the ponds holding these chemicals leak. This illustrates an important point in environmental science. When looking at impacts, you must include all of the effects, mining, extracting, processing, when trying to calculate the environmental impact of some process.